Form 3 Science, the particle theory of matter. Objectives. At the end of this lesson, children will recall the physical properties of matter and understanding the changes of states and changes in their particles, and also understand the gas pressure and diffusion. The particle theory of matter. The particle theory of matter states that all matter is made up of small particles that are in constant random motion. What is the meaning of that? We know all these matters made up of small tiny particles. So from these arrows you can see the movements of particles. It is indicating the movement of the particles. So these particles are moving constantly, that means non-stop, and randomly, no any particular pattern. Here and there it is moving randomly, and also it is moving constantly without stopping. Continuously the particles are moving. So that is the particle theory of matter. Now we'll see the arrangement of particles and the processes. This is, I am recalling your knowledge here. Already you have learned these changes of states in previous years. Now let's see, this is ice cube, solid states of water. So here they are indicating with yellow colors spots the particles, solid particles of this ice cube. You can see nicely they are packed tightly. There's no any space in between these particles. So this ice, when it is melting, it forms the liquid water. Ice, when converted into liquid water, we are giving the name melting for that process. And here again you can see the water particles by yellow color spots. Here you can see, compared to the solid, the particles are situating little with the little small spaces. It is not packed as much as in solid. Again, when this water boiling, it's gaining heat energy and convert into the water vapor. Water vapor forming clouds, you know that. So this water vapor is in gaseous state. It is the state of gas. Liquid water convert into gaseous water, we are giving the name evaporation or boiling. So here, when compared to solids and liquid, you can see the gas particles are situating little bit far away from each other. They are not really close. Now, if we see the reverse of this, water vapor, the liquid gaseous water is converting to liquid water. That phenomenon we call condensation. And again, when it is freezing, cooling more, the liquid water can convert to solid. It is we call freezing. Other than them, there's another phenomenon in between the solid and the gas. Directly solids convert into gas without a liquid stage. Normally we know we are learning solid, liquid, gas. Solid convert into liquid and liquid convert into gas. But here directly solid is converted into gas. So that phenomenon we known as sublimation. Sublimation. So these things you know well. I just wanted to recall your knowledge. Properties of solids, liquids and gases. In your previous classes you may have learned the physical properties of solids, liquids and gas. Just like they have fixed shape, liquids has taken the shape of the container, gas also like that. So these are the properties normally we are learning. But in this lesson we are going to discuss the arrangement of the particles, and because of these arrangements what kind of behaviors solids, liquids and gas possess. Let's see first of all arrangement of the particle. Solids. The arrangement of the particles regular. You can see here in this picture particles are nicely packed together in a particular pattern and no any spaces in between these particles. So they are regular. The pattern is regular. When we are talking about the liquid, it is not like the solid. You can see the liquid particles are here and there. It's not regular, it's random. And also you can see very little space in between the particles. So what about the gas? That's little bit different than the liquid. They are also random. The arrangement of the particle also random. There's no any particular pattern. And the distance between the particles, if we compare, we can see the solid very close to one another, no space, very close to one another. Liquid not very close, but you can say close to one another. It's not very close, but anyway the particles are close to each other. But in gas you can see far apart from one another. That means in between particles you can see lots of space. There's a huge space in between the particles. Movement of the particles. Solids, since they don't have any space, can't move freely. Only vibrate in fixed position. So not moving the particle, just it can vibrate at the same position. But the liquid able to slide over one another. Able to slide over one another, since there's a small space in between the particles, they have the ability to slide over one another. Gas move at high speed in all directions. Then you can see here the black color arrow is showing the random movement of the particle, right? So it is not, there's no any particular pattern here and there. It is moving in all directions, right? That means the gas particles have free movement. The forces attraction in between particles, since they are very close to each other in solids, the attraction forces between particles very strong. The liquid compared to solid, it is not strong as much as solid, but the solid has the strong attractive force with the other particles. But gas, since they are moving very fast here and there randomly, the if we consider two particles, in between that two we can't see any strong relationship or attraction. So their attractive forces are very weak. So if we are talking about the properties of the states of these particles, you can see the particle arrangement is very important. If you understand clearly the arrangement of particles, to understand their properties are very easy. Now let's see what's happened to the particles as they undergo changes in state as a result of cooling. Here we can see liquid is when comes to the freezing point, what happens? Heat is removed from the liquid particles and the particles lose energy and move slowly. As a result of that, the particles will be very close to each other. Some liquid particles lose sufficient energy for the particles to come closer together. Now, when the particles' energy decreases, so now they are moving very slowly. Since they are moving slowly, the attractions between particles will be increased. Therefore, the attractive forces in between particles are very high and strong. The forces of attraction between the particles get stronger. So, gradually after freezing point, when you are cooling more than the freezing point, it becomes solid. So when it is go be more less than the freezing point, so that is the solid states of the water. All the liquid particles at this time, all the liquid particles have lost sufficient energy and complete liquid water convert into the solid. Now the particles are in regular arrangement and they are vibrating only. They can't move here and there. So all the properties shown by a solids you can see here after they are cooling less than the freezing point. Gas pressure. What is gas pressure? The particles in the gaseous states are always in constant random motion. Now we learn the particles in the gaseous state, they are always in a constant random motion. Gas particles are constantly colliding with one another and with other objects. These are gaseous particles. You can see here the gas particles are randomly moving. These arrows are showing their movements. There's no particular pattern. They are randomly moving. Constantly they are moving. So at that time when they are moving, they are colliding with each other. Right? So gas particles are constantly colliding with each other. Not only that, the particles are colliding with the surface. When this particle hits on the surface, there will be a small force exert on the wall. Now you can see this particle hit on the wall and return. At the time of hitting on the wall, there will be a force exert on the wall, right? So this force exerted by particles on the surface we known as gas pressure. The particles colliding with each other as well as they are colliding with the wall. So the force exerted by gas particles on the walls are known as the gas pressure. Let's see the gas pressure with a small experiment. Here you can see a balloon before inflate. This is a balloon before inflate. What happens here is there's no air inside the balloon. So the gas pressure out of the outside of the balloon is higher than the inside. So at that time you can see the wall of the balloon pushed inwards. So it is like this. Now when you are inflating the balloon, what happens? You are inserting lots of gas particles into the balloon. You are pushing lots of gas particles into the balloon. Now after you inflate, the air particles inside the balloon is very high. So the frequency of the gas inside the balloon is higher than the outside of the balloon. So the gas pressure inside the balloon will be high. Why? Lots of particles are colliding with each other, as well as they are colliding on the wall of the balloon. So the pressure out from balloon to the outside will be high. Therefore, the wall of the balloon pushed outwards. Why? The gas pressure outside is less than its inside. There is a gas pressure from outside on the wall of the balloon, but it is not enough to stop the gas pressure which is inside. So as a result of that, the balloon is pushed outward and it is inflating and increasing in size. Let's see how temperature affects on the gaseous particles movements. For that you need two balls, one with ice water, the other one with the boiling water, and inflated balloon and the measuring tape. Now first of all you can keep the inflated balloon in the boiling water bowl and measure the size of the balloon. And again you can keep the same balloon in the ice water bowl. Keep some time and again take the balloon and measure the size. Here you can see the balloon inside the boiling water. The size is increased. The size of the balloon is increased. What happens here is, when the balloon kept on the boiling water, the heat energy absorbed by the air particles inside the balloon. After that, after absorbing energy, the air particles are increasing the movements of the particles. So they are highly active inside the balloon, and they are come and hit on the wall with the speed. So as a result of that, the gas pressure inside the balloon will be high. So the balloon increased in size at that time. The balloon size will be increased. So we can conclude, when the temperature is high, the gaseous pressure or gas pressure also increasing. Higher the temperature, higher the pressure. And when you keep the balloon in the ice ball, what is happening there? Now you know, when ice is there, so the energy in the particles, they are loose to the environment. Since the ball has the cooling water, now the heat energy of the particles are gradually passing to the ice water. So the particles are losing their energy, so their movements also decrease. And the movement, when they decrease the movement, the frequency of colliding will decrease, right? When the movement decrease, the frequency, the number of times hit on the wall will be decrease. Frequency means that the number of time the particles hits on the wall, so that will decrease. Then what is happening? Therefore, the gas pressure inside the balloon gradually decrease. So lower the temperature, lower the gas pressure. When temperature decrease, the gas pressure also decrease. Diffusion in gases and liquids. Now we are going to see what is diffusion, and the diffusion takes place in the gases and liquids. Diffusion in gases. What is this diffusion in gases? Now, if you go somewhere, now you apply perfumes. How this smell feel by others? How they felt it? How the perfume on your body felt by others? Even they are far away from you, they can feel it. Now, the behaviors of gases, they are in a constant random motion. So when you spray perfume, the perfume particles also add into this air and start to collide, then move with the gas particles. Now, while they move with the air, gradually they are going from the higher concentration place to the lower concentration place. Now, if you have applied perfume around you, the concentration of the perfume particles will be high. The concentration of the perfume particles around you will be high. Gradually, when these perfume particles moving and colliding with the air particles, they are moving to the lower concentrated area. We will explain that with this diagram. Here, these blue color particles are air particles, and the pink color particles are perfume particles. Now think, now when you apply the perfume, you are here. So around you, the concentration of the perfume particles will be very high, and this area no perfume particles at all. With the time, what happened? These air particles and the perfume particles are hitting with each other and gradually moving to the lower concentrated area. Like this. After diffusion, you can see here. So you can see these perfume particles are moved every direction. There's no any particular pattern. They are moving in every direction. So the gaseous particle has the ability to move from the higher concentration area to the lower concentration area. That is we call the diffusion in gases. Now we'll see the diffusion in liquids. For that, we will do small experiment. Here, there is a beaker with the water, and with the use of straw, we can add small amount of potassium permanganate at the bottom. For that, we can use a straw through the straw you can send directly the potassium permanganate to the bottom of the beaker. Then you have to keep it at rest for a little bit of time. Gradually you can see the color of the potassium permanganate is purple. The water doesn't have any color. Now gradually you can see earlier at the bottom the dark purple color is there. Why is that? Here the amount of potassium permanganate particles are high, and gradually this darkness is decreasing, and you can see the upper area getting purple gradually. And with the time this darkness completely decreasing and the other area getting darker, and finally the total beaker will be same one purple color, that no dark place or no light place, whole amount of the water will be in the same color. Here the color will be equal each and everywhere. This one we will describe with the arrangement of the particles. Now here at the bottom you can see, let's see, this is the potassium permanganate, and blue color particles are the water particles. And when the water particles are colliding with the potassium permanganate particles, gradually they are moving to all direction of the beaker, and water particles comes down, the potassium permanganate goes up, like that they are moving in every direction, and like this these particles are gradually moving up, and the water particles are coming here and mixing with it. After some time what happens, this potassium permanganate particles are equally distributed everywhere in the water, equally distributed with the water particles. That is why you can see the total area in the same color. Why is that? The potassium permanganate particles are equally distributed throughout the media. That is why the whole amount of water can see in the same color. So this movement of particles of water, this movement of particles in liquid, we known as the diffusion in liquids. This movement of particles, same like air particles, the particles are moving from higher concentrated area to the lower concentrated area. So here that is we known as the diffusion in liquid. The diffusion is the movement of particles from region of higher concentration, that means more particles per unit volume, to a region of lower concentration, that means lesser number of particles per unit volume. That is we call diffusion. Even in liquid air, the diffusion is the definition is the same. It is only changes the water particles and the air particles. Let's revise the things learned here in this lesson. We learned the particle theory of matter and the properties of matter and the arrangement of particles. As a result of that, the properties shown by these particles we learned, and melting, boiling, freezing, and the temperature effects of these melting, boiling and freezing, and the gas pressure, the effects of temperature on the gas pressure we learn, and diffusion in gases and liquids we learn in this chapter. So, to check your knowledge, you can do the Science Smart Workbook from page number 18 to 22. Thank you for listening. Thank you for watching. Let's meet with the next video.